Hi everyone, welcome. This is the first class that we will, or the first project that we will be working on. So today we will be learning about structured query language, or SQL or SQL. Either way would work. So SQL is used for relational database. So a lot of companies use relational database, and there are so many different relational database management systems that include SQL Server, which is by Microsoft, and we have MySQL, which is an open source, and we have Oracle, that is used by so many companies, that is also a relational database management system, and Microsoft Access, which is a very simple way that we can illustrate the use of. And a lot of companies, actually, a lot of small businesses still use Microsoft Access. So in this tutorial, we will be learning about how to use SQL to retrieve data. So a lot of companies that they have database or relational database management systems as their database, they need skilled workers who can retrieve data from their database management systems, so that way they can run reports or they can do some analysis. And to do that, we need to learn the foundations and the how to retrieve data. So in order to understand the anatomy of select statement in SQL, we need to first understand or know the keywords or the clauses that are included in a SQL statement. So as you can see here, the select statement or the select clause is the first keyword that we need to include. So the select and the from, they are a must in any query that we use for SQL. So select, and then so we start by typing select, and then from there we need to specify the names of the columns of that table. So let's say here I have a Microsoft database and I have different tables. So one of those columns or fields is called SKU, and then SKU description, department, and so on. Those are going to be used here in the select statement. So I will say select SKU, comma, SKU underscore description, comma, and so on. So that will be for the select clause. So now the next clause is the from. So the from clause here, I need to specify exactly what is the table that I want to retrieve this output from. So in this case, the name of the table is SKU from SKU underscore data. So I can specify the name of the table in the from clause. So the where clause here is also important when we want to pinpoint exactly what we really want to retrieve in our output. So let's say that I want to retrieve those records from this table that have camping as their department. So then I will put that in the where. So I will say where department equals camping. So that's in the where department equals camping in quotation mark, because the input here for department is actually data type is text. So I need to enclose that or have single quotation or single quotation mark around it to represent that this is a text data type. So then we have group by, and then we have having. So group by is used when we have aggregates. So what we mean here by aggregates include the sum, the count functions, the maximum function, the minimum function, and the average function, and so on. And having is also used in a similar fashion to the where, but having is only used when we have group by. If we have a group by clause, then and we want to pinpoint and based on an aggregate such as count, maximum, minimum, average, we use that in the having clause. So having clause is only for those for those pinpointing that is based on aggregate, such as maximum, minimum, count, average, sum, and so on. And then we use the order by clause here to sort our output based on ascendingly or descendingly, from low to high, from high to low. So now let's dig in and get started. So the first thing that I want to do, or I always do whenever I'm working with SQL to answer questions or queries, the first thing is I look at the schema or the entity relationship diagram, which basically is here, relationships. And now you can see that we have different tables, and those tables are connected through foreign keys. So in this table here, every table has a unique identifier. So in the retail order table, for example, and by the way, this database is based on an outdoor sports retailer. So they sell outdoor products. So now, as you can see here, the retail order table has a lot of fields that represent or that are concerned with the retail order, such as order number, store zip code, and so on. So now the identifier or the primary key is the order number. And this order number, when it is used in any different table other than its original table, then it is used, or we can call it a foreign key. So now order number is used in the order item table as a foreign key, but the combination of SKU and order number, the combination, we call it composite key. So the combination is a primary key for this table because the combination uniquely identifies every record in this table. So that's another thing. So now for this table, the SKU data, we have SKU as a primary key for this table, but it's also used as a foreign key by itself here, and also a foreign key that helps us connect those tables through the foreign key. So you got the idea. And now I like to always look at the relationships before I start answering those queries, because it tells me the relationships or the schema or the entity relationship diagram or the ERD here. It shows me the name of the table, it shows me the exact spelling of each field in that table, and how this will enable me actually to write my SQL statements very accurately, because I need to be very specific and accurate when I'm spelling out the names of the fields and the names of those tables. Another thing that I want to highlight is that SQL, especially SQL, is not sensitive to capital letters versus small letters, lowercase versus uppercase. So now let's dig in and get into SQL in Microsoft Access. So I will go to create, and then from create I can go to query design, then I will close out this guy and go to SQL here. So I have SQL here, I can go from here or I can go from here. I prefer to use this tab here, it's easier and faster. So now I can start typing. SQL is a language that I can actually use to calculate anything that I want. Let's say that I want to calculate 2 times 2, and I run. You can run it from here, and then you will get the product of it, the results. So now let's start by answering those 3 questions, and then I will stop the recording, and then I will continue recording the rest of this tutorial one step at a time. So now let's start by answering this question or writing the SQL statement for the first question. So let's select. So now it's asking me to list all unique buyers and departments. So now from reading this statement, I can tell that they want me to return, as in my output, buyers and departments as my output. So I will output buyer, and I will see exactly how it is spelled. So it is actually the SQ or the SKU data table. So I'll say buyer, and then they say department. So now I'll move on to the next line. You can actually write it in one line, will be fine, but for me I put it in different lines or different rows just for readability. So from now I need to specify the name of the table. So it is SQ underscore data. and then I can run it. So, but this doesn't necessarily fully answer the question. Here they said unique, but I will run it without unique first. So you can either run it from here, or you can run it by clicking on run. So now I have the output here, but if you notice that I don't have unique, so I have repeated values here, but here they are asking me to return list only unique buyers. So to do that, I need to go back to SQL, and there are some keywords that we are reserved for relational database. So for example, in here we can use a keyword called distinct. So select, and then I type distinct, and then it will I can run it. Now it will return only distinct buyers. So only distinct buyers. All right, so that's how we can solve this question. So for you, for your homework, you can save this guy. You can just save it, and let's say this is query 1. You can save it as query 1. Some people like to use prefix, which is abbreviations for queries, query, and then you can say query 1, and then you save it. It will appear here, and then you can submit this file, the Microsoft Access file. So now you can close this guy and go back, query. So now let's look at the second question. It's asking me show the top 5 buyers and departments. So now I can actually do so buyer and then department from here and then data. So now this is the full, so I have 8 records, but they said only the top 5 buyers. So I can use a keyword called top and then 5, and then this will return only 5 records. As you can see here, I have 5 records. So another so now you can, for example, that's why I provided you this Microsoft Access file, where you can actually save for your own records, for example here, the statements that you used. Some of you might ask, is this necessary, the semicolon end? In this file that I programmed for you, it's not really necessary, especially with Microsoft Access 2016. It doesn't require that semicolon at the end. So it should not be a problem if you don't have it. And again, this one here, I put it for a SQL statement. This is just for you, for your own records. But for you, you can save this guy for the homework, let's say, sake. Query 2, then you can save it. So now, the next one, you can also copy this guy if we want to do the number 3. So number 3, they want us to show the top 75% of buyers and departments. So I can actually copy this guy. So let's say copy. All right, so now it should have copied it, and then I can paste it, and I can call it query 3. All right. So now I can say top 75%. So 75, I need to spell out the percent. So 75%, I can run it, and then I will get my output. So you get the idea. So 75% out of the 8 records, I have 6 records. So you get the idea here. And so I will continue with other follow-up videos that will illustrate the rest of those queries. So see you soon.